What if you could look at any object and know exactly what it's made of? It's not magic, it's science. Today, we re-unlocking the secret code of materials by exploring the 10 key properties that scientists use to identify all matter. Are you ready? Let's begin. Our first and most obvious clue is color. Now, I know what you're thinking. Color? That's it. But hold on, every substance has a unique color or shade that acts as its initial fingerprint. It's the first piece of information our brains process. For instance, the vibrant purple of an amethyst is a dead giveaway. You see that specific shade, and your mind immediately goes to that beautiful gemstone. But beware, color can be a trickster. Many different things can share a color, so while it's a great starting point, we need to dig deeper to truly identify a material. Think of it as the cover of a book. It gives you a hint, but you have to open it to get the full story. Next, let's talk about hardness. This isn't about how heavy something is. It's about the material's resistance to being scratched or dented. To measure this, scientists use the Mohs scale, which ranks minerals from 1 to 10 on the softest end. At number 1, we have talc. It's so soft, you can literally scratch it with your fingernail. Think about talcum powder dust, how easily it breaks down. On the absolute hardest end of the scale, at a perfect 10, we have the legendary diamond. A diamond is so hard that it can scratch almost anything else on earth. It has this incredible hardness that makes it not only a prized gem, but also a crucial tool in cutting and drilling. So, when you see a material's ability to resist a scratch, you're directly observing its hardness. Now, for a property with some bounds, elasticity. This is the amazing ability of a material to return to its original shape after being stretched, squeezed, or bent. It's a measure of its flexibility and resilience. The perfect example is a spring. You can compress it, you can pull it, you can twist it, but as soon as you let go, it springs right back to its perfect, coiled form. Another great example is a rubber band. You stretch it out to hold things together, and once you take it off, it snaps back to its smaller size. This property is crucial in everything from the suspension in your car to the waistband on your pants. Elasticity is all about that comeback. Some materials have a highly superpowered magnetic property. This is the ability to attract specific metals, most famously iron, steel, and nickel. It's a very selective force. A powerful magnet will completely ignore a piece of plastic, a block of wood, or a sheet of aluminum foil. But bring it near a paperclip or a steel nail, and it will jump to grab it. This invisible force is at the heart of so many technologies we use daily, from the motors in our appliances to the way our computers store data. It is a fundamental force of nature that allows us to distinguish between certain metals and pretty much everything else just by seeing if they respond to its pull. Now, let us get to the core of what makes something feel heavy or light for its size. Density? You've probably heard the classic riddle, what's heavier, a pound of feathers or a pound of lead? The answer, of course, is that they weigh the same. But the reason it's a trick question is because of density. The formula is simple. Density equals mass divided by volume. In other words, density is all about how much stuff or mass is packed into a given space. A small, heavy bar of gold is incredibly dense because it has a lot of mass packed into a tiny volume. A huge, lightweight pillow, on the other hand, is not dense at all. It takes up a lot of space, but has very little mass. So, density isn't just about weight. It's about how concentrated that weight is. What happens when a solid meets a liquid? We find out with our next property, solubility. Solubility is a substance's ability to dissolve in a liquid and form a uniform mixture, which we call a solution. It's something you see every single day. If a substance seems to vanish into the liquid, like when you stir sugar into your coffee or salt into water, we say it's soluble. It breaks down into tiny particles and spreads evenly throughout the liquid. But what if it doesn't dissolve? If you drop sand into a glass of water, it just sinks and sits there at the bottom, no matter how much you stir. In that case, we call it insoluble. This simple test of dissolving or not dissolving is a powerful clue to a substance's identity. Let's turn up the heat with our first temperature-specific property, the melting point. This is a very precise property. It has the exact temperature where a solid can no longer hold its rigid structure and transforms into a liquid. The most famous example is ice. For pure water, this magical transition from solid ice to liquid water happens right at 0 degrees Celsius or 32 degrees Fahrenheit. It's not a gradual process, it's a specific threshold. Below that temperature, it stays solid. At that temperature, it begins to melt. Every pure crystalline solid has its own unique melting point, whether it's ice, chocolate, or a block of iron. It's a definitive fingerprint that helps scientists identify a substance with great accuracy. Now, let us keep turning up the heat even more to reach our next critical threshold, the boiling point. This is a specific temperature where a liquid gets so energetic that its particles start to escape and it turns into a gas. For pure water at sea level, this rolling, bubbling transformation happens at exactly 100 degrees Celsius or 212 degrees Fahrenheit. When you see a pot of water come to a vigorous boil with lots of steam rising, it has reached its boiling point. Just like the melting point, the boiling point is a unique and constant characteristic for any given pure substance under standard pressure. For example, ethanol, the alcohol in some drinks, boils at a much lower temperature of about 78 degrees Celsius. This difference is precisely why we can separate different liquids through a process called distillation. How does matter handle heat? That's determined by its thermal conductivity. This property tells us how well a substance allows heat to travel through it. Good thermoconductors, like most metals, transfer heat rapidly. That SYA metal spoon left in a hot bowl of soup gets hot all the way up the handle very quickly. The heat energy zips right through it. On the other hand, we have good thermal insulators like wood, plastic, or air. These materials resist the flow of heat. That SYA wooden spoon is much safer to use for cooking. It stays cool to the touch even when the other end is submerged in boiling water. This property is why we wear woolly jumpers in winter and why our homes have insulation in the walls. Finally, let's explore how matter handles electricity. This is all about electrical conductivity. Similar to thermal conductivity, this property measures how easily an electric current can flow through material. Materials like copper, silver, and even the graphite in your pencil are excellent electrical conductors. They allow electric charge to move freely. This is precisely why copper is used in all our electrical wires. It gets power from the outlet to our devices with very little resistance. In contrast, materials like rubber, glass, and most plastics are electrical insulators. They block the flow of electricity almost completely. They are the protective shields wrapped around wires that keep us safe from electrical shock. This fundamental difference between conductors and insulators is the basis of all modern electronics. And there you have it, 10 powerful properties that let you decode the world around you. Color, hardness, elasticity, magnetism, density, solubility, melting point, boiling point, and both thermal and electrical conductivity. You're no longer just looking at objects, you're analyzing their secrets. With this knowledge, you can start to see the science behind everything, from the spoon in your coffee to the phone in your hand. Which of these properties do you find the most fascinating? Challenge us in the comments. Describe an object using a few of its properties, and we'll try to identify it. If this guide helps you see the world a little differently, please support us by hitting that like button, subscribing to the channel, and turning on notifications so you don't miss our next science adventure. Thanks for watching.